So let's take a moment to review some of what we've learned so far. Okay, we've learned that there are certain criteria for proving two triangles are congruent. One of them is side, side, side. One of them is side, angle, side. And another one is angle, side, angle. Okay, there actually are one or two more that we're going to learn. But not all combinations of sides and angles are enough to prove that two triangles are congruent. And now we're going to see one example, and in the next lesson, later on, we're going to see another example as well. So let's go ahead and let's move to number 7. And this is one of the counterexamples, or one of the examples that shows a combination that cannot prove congruence. Measure all the angles in triangle ABC and triangle RST. Now, I'm not going to go ahead and measure these, but I assure you they're all pretty close to 60, maybe 1 or 2 degrees off. But of course, the printing is not perfect. But the purpose here is to show you two equilateral triangles. Now, we learned previously that equilateral triangles have all of their angles equal to 60 degrees. So, assuming these are both equilateral triangles, we can say each of these angles is equal to 60 degrees, as well as each of these angles is equal to 60 degrees. Are these two triangles congruent? Is there any way I could trace this one with patty paper and have it fit exactly on top of this one? I don't think I need to do the patty paper demonstration, but if you'd like to go ahead and try, you're welcome to do it. But hopefully you will conclude that the two triangles are not congruent, okay? That there's no way you could place this one directly onto this one so that they will overlap. This one is just too big, right? And this is too small compared to this one. So we can conclude that triangle ABC, and we'll just write is not, we'll put a line through the congruent sign. Triangle ABC is not congruent to triangle RST. However, there are congruent parts of the two triangles. In fact, each of the angles are congruent to corresponding angles. So angle A is congruent to angle R, angle B is congruent to angle S, and angle C is congruent to angle T. Why are all those angles congruent? Because they're all equal to 60 degrees. Okay, so by transitivity, if this angle is equal to 60 degrees, and this angle is equal to 60 degrees, they're both equal to the same thing, which makes them equal to each other. So the measures of all the corresponding angles are equal. So we have here angle, angle, angle. Okay, we've got two triangles with corresponding angles, all congruent. But the triangles themselves are not congruent. So we have to say that angle, angle, angle is not a triangle congruence criteria. Okay, you cannot determine that two triangles are congruent simply because their corresponding angles are congruent. Okay, so angle, angle, angle is the first example we've seen, or AAA is the first example we've seen where we cannot conclude triangles are congruent. So let's go ahead, move down a little bit, look at these examples. Each of them gives us a different set of triangles with different parts of the triangles being congruent, and we need to conclude at the end whether or not the triangles are congruent. Okay, so we have to complete the reason in the statement. The triangles are not congruent, write not congruent. So let's start with number 8. So we're told that angle E is congruent to angle M, which means that E and M have the same measure. Go ahead and zoom in a little bit more on this. I'm going to show you a slightly different notation that's commonly used for congruent angles. we're just gonna write like that. A single curved line representing that E and M have equal measures. Side EG and side MO are congruent, which means they have equal measures as well. And angle G and angle O are congruent, and what we're going to do is we're going to put two curved lines next to G and O. Okay, so this is another way of representing congruent angles, by the number of curves that you put in. E and M are congruent because they each have one curve, and G and O are congruent because they each have two curves. And EG and MO are congruent line segments. They each have one dashed line going through their sides. So what about these triangles? Are they congruent? Can we conclude the entire triangle is congruent? Well, we have an angle, a side, and an angle that is congruent. So angle side angle is one of the ones that is a congruence criteria. So we can say that triangle EFG is congruent to triangle, that we have to be very careful. We're saying EFG. The order here does matter, so that when we try to see how we're going to call this triangle, we learn that there are many names. We could call this triangle MON, ONM, MNO. You could use these three letters in any combination to refer to this triangle, but when you're talking about congruence, you have to have corresponding angles and corresponding sides matching up. It's very important that they match up, so that the first letter that occurred in this first triangle is E, and E was the angle with a single line, curved line. So we have to start this triangle with the angle that had the single curved line, which in this case is M. Okay, so M. And the second letter now is F. F is the angle that doesn't have anything. Okay, it has no markings. That would correspond to N in this triangle, so we're going to have to put N. And finally, G is the angle with the double bar, and so therefore we have to end this with O, which is the corresponding angle in this triangle. So when we write the congruence, we have to be careful that we put it in the right order. And the reason here was angle side angle.